Every year, 6.5 million tons of plastic ends up in the oceans. This is the same as 3,200 kilometers of trucks, each loaded with garbage. The Earth is sinking in plastic, and unless we take urgent action, by 2050 there will be more plastic than fish in the seas. This is a global problem that requires international cooperation for an urgent global solution. Satellites provide a global view and allow us to monitor the Earth, generating terabytes of data that could potentially be translated into relevant information, leveraging the latest developments in artificial intelligence. So one question emerges from a sea of uncertainties. Can satellite data and AI help us solve marine litter pollution? This is the challenge. To talk about the AI Moonshot Challenge, please welcome Gilles Coelho.
Welcome to the finals of the first edition of the AI Moonshot Challenge, brought to you by Portugal Space in partnership with Embabel, the European Space Agency and the Portuguese Innovation Agency. All of this made possible through the sponsorship from FCT, the Portuguese Foundation for Science and Technology. Inspired by the moon landing 50 years ago, the goal of this challenge is to promote innovative ways to tackle societal problems by exploring the new possibilities opened by the intersection of AI and satellite imagery. Our focus for this first edition is the global issue of plastic in the oceans, and we will award up to a total of 500,000 euros for teams to conduct research from Portugal, effectively attracting the best talent in this area and positioning Portugal as a leader in this emerging domain. We have received proposals from a consortium involving 38 institutions, not just from Portugal, but across the world, coming from countries such as the United States, Netherlands, Greece, and Germany. Teams included not just leading research centers, but also NGOs, companies, and startups. To evaluate each proposal, an international panel was assembled with experts from ESA, University of Hawaii, University of Oldenburg, NASA, Embabel, and Portugal Space. Criteria such as innovation, scientific merit, and expertise of the team were used to choose the top 3 teams that will be pitching today. From the jury, we will be joined by Carolina Sá, Paulo Corradi, and Vasco Pedro. Each team will have 3 uninterrupted minutes to pitch without Q&A, and the winner of up to 500,000 euros in funding to conduct research from Portugal during the next 2 years will be announced Friday, the 4th at 4 p.m. in this same channel of Web Summit. Best of luck to the teams. Thank you.
It's estimated that more than 5 million tons of plastic enter the ocean every year. This is a serious problem because plastic breaks down into many microplastics which are nearly impossible to remove from the ocean, and they can take centuries to completely degrade. These microplastics are easily ingested by marine life, and therefore the whole marine food web is at the risk of becoming contaminated. So we need to take urgent actions, and one is to find where the plastic is accumulating. Large accumulations of floating plastic, such as the ones in this slide, they can be detected by the new satellites from ESA Sentinel-2, which have spatial resolutions up to 10 meters. These patches are seen by Sentinel-2 as bright objects with a high reflectance in the near infrared. One problem is that other floating materials, such as floating algae, are also bright objects, so it's currently difficult to tell whether a bright object in a satellite image is floating plastic or something else. Another problem is that to get the ocean reflectance, we first need to remove the atmospheric contribution with special algorithms. These algorithms introduce errors into the reflectance, which further complicates the separation of the different floating material. In this project, we will focus on these 2 issues using artificial intelligence with the objective of delivering an automated method for detection of plastic patches with Sentinel-2. The team is composed by researchers from the Mare and Laziz centers from the University of Lisbon, the Mare Center from the New University of Lisbon, and the Plymouth Marine Laboratory from the United Kingdom. We will start by creating a large library of the spectral signatures of various floating material in Sentinel-2 data. To this, we will also add the signatures of the artificial plastic targets that we will deploy in a Portuguese coastal lagoon. Then we will improve the atmospheric correction by testing and validating a novel data-driven approach. Once these tasks are done, we will apply artificial intelligence on the library in order to find meaningful patterns between the spectral signature of the different floating materials, including plastic, and the detection algorithm of floating plastic will be developed. Finally, we will perform a pilot study in a coastal region where we will run the full process over several years of data. With this project, we aim to improve significantly the remote sensing of marine plastic pollution and the automatic detection of floating plastics on a global scale. Thank you for listening.
Representing the jury, please welcome Carolina Sá.
Hello everyone. So this first project, Implast, captured the jury attention and was selected to pitch today for being a very solid proposal that builds on top of consolidated research while promising to advance the state-of-the-art of marine litter detection from space, and in particular with the open space data from Sentinel-2 satellite, which is part of the Copernicus fleet. The team targets to create a comprehensive library of marine litter images from Sentinel-2 and deploy artificial intelligence to differentiate plastic from different floating litter and debris. The team will put also efforts to improve the atmospheric correction, which in our view is also a very important aspect to improve in the domain of remote sensing of marine litter. And on top of that, the very experienced international members of the team propose a very interesting knowledge transfer to Portuguese researchers. I should say that we have received very good quality proposals, but unfortunately we had to select only a few to pitch in this session, and I hope you enjoy all the presentations. Have a great afternoon.
The way we handle plastic pollution in the oceans today will define our future and the future of countless marine organisms and ecosystems, and influence public health, food security, and the simple pleasure of enjoying a clean beach. To address this problem and clean our oceans, we need to know where the plastic is coming from and where it is going to. This is a daunting but needed task. And this is our mission on Project Atlas, which brings together several highly experienced and motivated teams into one interdisciplinary consortium, including stakeholders from many domains, backgrounds, and visions. With several key partners which will join our advisory board, we analyzed user needs and requirements and realized Earth observation, aided by advanced data mining solutions based on artificial intelligence, would allow us to deliver the actionable information products needed to meet the legal, scientific, and ethical requirements highlighted by the community of sea users backing Project Atlas. We'll bring experience gained from previous projects working together to deliver a multi-layered, near real-time solution to detect and model plastic litter in coastal waters of Portugal, which we will further validate in California. Atlas will rely on data from multiple satellites in a virtual constellation of opportunity, offering plastic potential, direct detection, and target displacement forecasts, which will be delivered in 3 different runs and latencies depending on the sources of information available for each version. To do so, we'll need high-quality ground truth data, which will be collected using conventional as well as innovative methods, like our autonomous platform, which will allow us to keep station and deploy marine and aerial assets where and when they are needed the most. The complexity of such undertaking calls for an articulated response by each partner in our seasoned team, from ground truth data collection to image processing and delivery, as well as from our end users who will assess the adoption and operational use of the products. The workflow will be summarized into a scalable and reusable framework, the Atlas framework, which will establish a global network of networks integrating science teams, companies, and stakeholders in a coherent model for a global integrated observation network. We asked for nearly 490,000 euros in order to realize this vision. We can, through the AI Moonshot Challenge of PT Space, deliver the first pre-operational regional marine leader observation network as a stepping stone towards a global integrated solution of independent networks operating under a common set of standards. We can stop plastic pollution, and we will do so using global science, but local knowledge and resources.
Representing the jury, please welcome Paolo Corradi.
Hello everyone. The Atlas project stood out as it proposes the concept of an integrated solution combining multi-source ground truths with data from drones and satellites in a processing platform employing artificial intelligence. The project has the ambition to demonstrate this at a regional level in Portugal, creating what could become the first local network of a future global integrated network of platforms, sensors, and AI processed data on marine litter, which is in line with the community efforts toward the Integrated Marine Debris Observing System, or IMDOS. This is a strong proposal from an international team with diversified expertise.
Hi there, my name is Leonardo, and I'm here to tell you more about a distributed artificial intelligence system for marine plastic debris monitoring, or SMART. As inhabitants of the planet Earth, we have a major problem at our hands, and that problem impacts all of us, the plastics and the floating debris in the oceans. It is estimated that 80% of all the marine floating ocean debris are marine plastics, reaching a total amount of 1.5 million tons of plastics located in the superficial surface layers of the ocean. There is no doubt that floating plastic debris are a global threat to wildlife and human health, as they are eventually ingested by marine species or act as traps, causing severe injuries and even death for marine life. If not identified and removed quickly after entering the ocean, these plastics will degrade into smaller pieces and eventually end up in the food chain of animals and humans. It is absolutely vital that we take action and address this critical global dilemma now. Well, while this problem may seem overwhelming and insuperable, I would like you to take a moment to imagine the tool that allows humans to predict the most probable locations of marine floating plastic debris as soon as they enter in our precious oceans. A tool that allows scientists to observe the evolution of the system both forwards and backwards. Imagine that this tool will enable the local, national and global authorities to work together and develop strategies for ocean cleanup and to identify hotspots for plastics accumulations. You are lucky, you no longer need to imagine. The Distributed Artificial Intelligence System for Marine Plastic Debris Monitoring, or the SMART Consortium, has the answer and will provide this tool and make it available to the community. As a consortium, we will leverage the breadth of experience of the SMART researchers and scientists from across the globe. We will use physics-guided deep learning combined with large amounts of satellite data and high-resolution numerical ocean models. These will be validated in situ by autonomous marine vehicles and citizen science to create the probability of plastic maps. This will allow authorities to create strategies for ocean remediation while taking and making decisions under uncertain conditions. SMART is a unique research project to be developed in the next 2 years through 4 complementary work packages. It is also a collaborative effort and a unique ecosystem formed by Portuguese academic institutions, the Portuguese Hydrographic Office and the MIT Portugal program. With the support of the AI Moonshot Challenge funding, the team can harness the unmatched experience and the knowledge of our diverse consortium to create a game-changing tool for our precious oceans, a resource we cannot afford to jeopardize further.
Representing the jury, please welcome Vasco Pedro.
SMART is an ambitious, multifaceted project that will combine measurements from various advanced sensors that will be input into an AI processing framework and validation tool for mapping plastics. The team will exploit deep learning for processing satellite data, AI-based transport modeling and autonomous marine surface vehicles as in situ validation platforms in order to create a physics-guided spatiotemporal mapping of probability of occurrence of plastic pollution at sea. They display great knowledge over the state-of-the-art when it comes to physics-informed neural networks and even of GANs, which is an interesting concept we haven't seen applied in the area before.
Thank you to the shortlisted teams. The winner of the AI Moonshot Challenge will be publicly announced later during the Web Summit. May the best proposal win.